All right, so here's the last video in the three-part epic series of angles in standard position. So here we've got four angles in standard position where the terminating arm ends in different quadrants. Okay? In each case, the coordinates are very sort of similar in that in this quadrant 1, when we draw a reference triangle between the terminal arm and the x-axis, it's there. In quadrant 2, it's there, so this is quadrant 2. This is quadrant 1. In quadrant 3 down here, by the way, I put my little reference angle. In quadrant 3, the reference angle and reference triangle is there. And in quadrant 4, it is underneath. So same kind of coordinates are in play, but the sign of them is going to change the x and the y sides. So 3 over 4 up in quadrant 1. But in quadrant 2, it's 3 to the left, so negative 3, 4 up. In quadrant 3, it's 3 to the left, 4 down, so they're both negative. And in quadrant 4, it's positive 3 to the right, 4 down, so negative 4. So one way of looking at it is really all I just did was I took the x and y coordinates and I put the x on the bottom and the y sort of going up in each case. And if, like say down here, right, if the y coordinate happened to be negative, I labeled that side with a negative number. Okay? All right, so let's do the three trig ratios for each angle. Let's start with cosine. So over here, when I'm on the sort of the right side, okay, right or left, so I'm doing the right to quadrant 1 and 4. Let me just put quadrant 4 in here. When I do that, my cosines are going to be the same. Cos of theta, in this case, is going to be adjacent, that's the bottom side, x over hypotenuse, or r. Well, notice right below it, when I do adjacent over hypotenuse, I still get 3 over 5. So in quadrants 1 and 4, cosine is positive. When I go over to the left two, that is quadrants 2 and 3, I see that. I'm just going to grab something and move it here for a second. Let's get this over here. Give me some room. Okay, so when I do it on this side, notice my bottom side, my x side, is going to be negative this time. So cos of theta here is going to be x over 5. Gives me a negative result. And on the bottom here on quadrant 3, cosine's also going to give me negative 3. So notice the thing that seems to control whether or not cos is positive or negative is that x side. So when I'm in quadrants 1 or 4 on the right side, it's positive, and when I'm on the left side, they're both negative. Okay? So x controls cos. So you can kind of think about that. The sign of x controls this. The positive or negative sign of x controls the cosine. Okay, so that's what cos is all about. Let's take a look at now. Let's draw the line that way. Now let's do the sine ratio of the top and bottom. Okay, so sine up here is going to be 4 on 5. Okay, opposite over hypotenuse. In quadrant 1, over here, it's also 4 on 5. Okay, well, it's positive because both of those y values are positive. So sine is positive whenever the y side is positive. Okay? So in the bottom, notice that both of these y values are negative 4. Well, sine of theta then in this case is opposite over hypotenuse. There it is. It's negative down there. And over here in quadrant 3, sine is also negative 4 over 5. So if x controls cosine, y controls sine in terms of whether or not they're going to be positive or negative. All right. Now, the last thing is tan. Okay, tan we said was like slope. So let's think, in which two quadrants is slope positive? Well, slope is positive whenever we're rising to the right. So those terminal arms both have positive slopes. Well, let's watch what happens when we calculate tan. Here. Tan of theta is equal to, well, it's the opposite over the adjacent, or the y over the x. So in this case down here, it's negative 4 over negative 3. But since they're both negative, we end up with just a positive fraction. And up here, tan of theta is equal to opposite over adjacent, so they're positive. So when the terminal arm is in a quadrant that has a positive slope, then tan is going to be positive. Well, if that's true, then on the other end of it, when we have negative slopes, okay, we can see that the tans should be negative. I did it again. So let's work out the tan. So here, tan is equal to opposite over hypotenuse, opposite over adjacent. Opposite over adjacent, 4 over negative 3. Okay, there's just one negative in there, so tan's going to be in the negative fraction, negative 4/3. Down here, same deal. Okay, opposite over hypotenuse, negative 4 over 3 gives us that same negative fraction. So it's possible to have kind of 4 angles all around this sort of grid in the different quadrants that end up with the same numbers, but sometimes they're positive and sometimes they're negative, depending on where they are on the set of axes. So as a recap, x controls the sign of cosine, y controls the sign of the sine ratio, and slope controls whether tan is positive or negative. So what value decides whether cosine ratio is positive or negative? X. Which value depends on, which sort of affects the sine ratio? Y. And tan? Slope. So let's just say here, just answer the question. In which quadrants is tan ratio positive? Quadrants 1 and 3. And where is it negative? In 2 and 4. All right. So then, let's see here. So, oh boy, this just keeps on going. Okay, so if sine A is positive and cos A is negative, in which quadrants does the terminal arm terminate? All right, so we have to now think. Sine A, we're going to think, is sort of controlled by the y. Cos A, the cosine ratio, is controlled by the x. So if sine is positive, that means the angle is somewhere where the y is positive. So it's somewhere up there. Okay? All right. If cos is negative, then x is negative. And we must be somewhere where x is negative, which is in these two quadrants. Okay? Because x is negative there. So the only quadrant that satisfies both of them is that quadrant right there. Because if I draw a line here, when I'm in here, that means my angle must be in quadrant 2, and the terminal arm must terminate there, because that's where sine is positive and cos is negative. Now, if I'm in that quadrant, I must be between Well, 90 is there. 180 is way down here. So if I'm in quadrant 2, I must be between 90 and 180. Okay? Let's try another one. So you guys can stop the video and think about this and try this one. So if tan B is negative, let's try and remember that. So that's where slope is negative. And if cos B is greater than 0, well, that means it's positive. That means if cos is positive or greater than 0, that means x must also be positive. So we need to figure out which quadrant has a cosine that's positive. Well, cosine, where x is positive on this side, and tan is negative when we have a negative slope. So those two quadrants, right, have negative slope term line in standard position there. So which quadrant satisfies them both? It would be that one. So that means our angle terminates there because that's where the slope of the terminal arm is negative, tan is negative, and the cosine is positive because x is positive. So if we're in there, we're past 270 degrees, but haven't gone as far all the way around to 360. So we're in between 270 and 360. All right, so one other way to help remember the positive and negative rules for sine, cosine, and tangent is the cast rule, it's called. Because here, all of the sine, cos, and tan, all of them are positive. Here, only sine is positive. It's the only one that's positive. Down here, tan is the only one that's positive. Let me just fix my writing here. Tan is the only one that's positive, and over here, cosine is the only one that's positive. So, you know, cast. Okay. And last but not least, let's put it all together. So angle beta, beta is just another Greek letter like theta. Beta is an angle in standard position. If beta is between 0 and 180, so we know it's in the top half of the grid, and we know cos is negative. Cos is a negative number. What are the other two trig ratios? Well, first of all, if we're for sure got to be between 0 and 180, we for sure got to be in the top two quadrants because all the angles there go from 0 to 180. And if cos is negative over here, well, that's telling us that by this process of elimination, we have to be in quadrant 2. So let's start by just sketching in an angle in quadrant 2. We are also told now I'm also going to call this beta, and this is beta r. So if cos is equal to negative 4 over 7, we know that cos is also the adjacent side over the hypotenuse, or that's the x side over the r side. Well, that tells us I can start putting in some side lengths. So this is the adjacent side down here. The x side is 4. But since x can, it's going to the left there, I'm going to call that negative 4. And r is 7. That's the hypotenuse. So I'm just going to call that 7. And that one's always positive. And if I made a fraction of those, negative 4 over 7, I would have cos, which I do. Okay? So in order to get the other two trig ratios, I need to know what y is. I need to know that side. Well, that's pretty easy to do. Let's just set up the Pythagorean theorem. So that's negative 4 squared plus y squared equals 7 squared. Okay? So 16 plus y squared is equal to 49. Subtract 16 from both sides. Y squared is equal to 33. Okay? Now, if you remember, whenever we use square root, we got to go do the plus minus thing there. So y is either equal to the positive or negative square root of 33. Now, given the fact that it's going up and it's in a spot where y is positive, we know, well, it can be either one, but we know that in quadrant 2, y is positive. So I'm going to go ahead and just say that that's positive root 33. Okay? It also makes sense. I mean, yeah. Anyway, I'll leave it at that. So then the other two trig functions would be sine. Sine of beta is opposite over hypotenuse. And tan is opposite over adjacent. A negative fraction for a negative sloped terminal arm. Okay, and for the last example, it's the same deal. We're going to figure out which quadrant we're in, and we're going to draw the triangle and kind of go from there. So tan here is positive 1/3. Where is tan positive? Tan is positive where the slope of the terminal arm would be positive. So it's either in one of those two quadrants because the slope's going up. Sine is less than 0, so sine is negative. Where is sine negative? Well, sine's negative where y is negative, so down below there. Okay, so if we look at that, we can see there it is. It's got to be in that quadrant. So let's draw our angle and call it A. Alrighty, so there we go. There's our reference triangle. We're going to put A sub r for our little reference angle guy in there. Now, how do we label the sides? Well, we need to know that tan is opposite over adjacent. Well, opposite over adjacent, well, opposite, that's kind of like y. Adjacent, that's kind of like the x. So no matter how way you slice it, opposite our reference angle is a 1, and adjacent to our reference angle is a 3. Now, here's where we kind of have to be kind of smart about this. Given that it's 3 to the left, we know that should be a negative. And given that it's 1 down, that should be a negative 1. So really what happened when tan A was being written before, based on its location, it would have been negative 1 over negative 3, but the negatives would have canceled out. And we would have just 1/3. But they both have to be negative for that to happen, and that makes sense in that quadrant. Okay, using the Pythagorean theorem, we get negative 1 squared plus negative 3 squared equals hypotenuse squared. And that's 1 plus 9 is equal to r squared, square root both sides. So r is either equal to, we know we should go plus or minus, but because r is always positive, that's just positive root 10. So then sine of A would be opposite, negative 1 over hypotenuse or r, which is root 10. And cos of A should be negative 3 adjacent over hypotenuse root 10. And there you have it. That's how to find the sine, cos, and tan of any angle all around from 0 to 360.